So here another interesting problem. Here which states that if the pressure in the airspace above an oil surface in a closed tank is 115 kilopascal absolute, what is the gauge pressure 2 meters below the surface? So simply here we have a closed tank. So that could be really a tank which is a container of oil. In this case, we'll make a cylindrical tank. Assume that to be vertical. So it is closed, meaning it's not open to the atmosphere. And here, perhaps the oil is in here. And here, there is a free space in which contains air, roughly air and vapor of oil. Now, in this case, the pressure here is known to be at this space. The pressure here is 115 kPa. No? kPa absolute, and we write that with absolute there. That's the idea, 115 kilopascal absolute. And we are asked for what is the gauge pressure 2 meters below the surface. So 2 meters below the surface, so simply if this is the surface of the oil, then 2 meters below that, so somehow it will be here, assuming of course that this distance between there and there is, shall we say, 2 meters. Okay, so here we could note, actually here we could have here, really this we call this here as our point A, and we could call this point here as our point B, just to make the things or analysis simpler, where point B is 2 meters below the free surface, which is point A. Take note that this is not filled with oil, but kanir ang imuhang oil. Usually draw this triangle to denote marag bangka nagluto-luto, so to denote a free surface. Now, question is, what is PB? So we're looking for PB. We're given that this oil has, oil floats in water. That's why oil has a specific gravity of less than 1, which is 0.75. That implies, of course, that raw of the oil, the density of the oil is 750 kilogram per m cube. And, as simple as that, 750 kilogram per m cube. Here, there are a lot of ways to solve for PB. But to solve for that, we could just note that the air here above this, the pressure at point A is really equal to the pressure of the air on this part. The pressure really for gases is dili kasi magmudako by as you go deeper on the gas, because the density of gas is very small. So essentially, this whole space here has a pressure of 115 kilopascal absolute, and therefore point A will also have that pressure. So we know that PA has a pressure of 115 kilopascal in terms of absolute. There are a lot of ways to solve this. Since we're looking for PB in terms of gauge, you could just simply solve for PB absolute first, then convert that to gauge later. Okay, I think that's what we do now. Now, how will we be able to solve for PB? Simple. As you go deeper, we know that the fluid or the pressure increases by rho gh, and therefore we have in here, well, that's PA, so that's pressure at point A, that's 115. This is absolute, so there's 115, but we write it in terms of Pascal, 115, okay, 1000. And as you go deeper, that will be rho gh. So, okay, I'll just write PA plus rho gh equal to PB, the pressure at point B, which we are looking for. 115 plus rho, which is rho in this case is 750. Because it's given that S is 0.75, you multiply that by density of water. 750 times 9.81 times H, which is, well, H is the depth, lower than that by 2 meters, and therefore that's PB. Take note that what we solve here for PV is absolute pressure because we are using here PA, absolute pressure. Therefore, PB is equal to, ilan ang PB? PB is 129,715. 715. Ang unit is Pascal, and we put here absolute because we just want to be consistent. So if we use here PA to be absolute, then dapat ay mong PB nga na measure is absolute po. But we're really looking for not absolute pressure, we're looking for the gauge pressure at PB. So therefore, this is equivalent to saying, how do you get absolute by gauge? Of course, always it will be what? PB absolute is simply equal to PB, PB gauge plus, we'll write here, P absolute is simply equal to P gauge, gauge plus P barometric, meaning the pressure of the atmosphere sa gawas, sa surrounding air. And if we're not given with the actual barometric pressure, we assume that this is 1 atmosphere, or in standard SI it will be 101,325 Pascal. So here, therefore, P absolute is known to be 129,715 Pascal, and therefore PB gauge will then be here G to signify that it's gauge, and P barometric is 101,325 Pascal. Therefore, right here, therefore, what we really are looking for is equal to PB is equal to 28,390 Pascal. And this is gauge. We don't need to put really gauge because if we don't put gauge, it is assumed to be gauge pressure. What does this mean? This simply means that the pressure at point B is 28,390 Pascal, or that is 28.4 kilopascal higher than the surrounding. Meaning, ang pressure sa B is higher by 28.4 kilopascal than the surrounding air. So, inuna na lang ang idea. Take note na kani siya sealed. Kung wala pa ni siya gi-seal, the pressure here is just 1 atmosphere absolute, meaning open to the atmosphere. Okay, that's it.